All right, today is Unit 8, Day 2, so second day of this guy. Yesterday we just did like general patterns. Now we're going to really focus on arithmetic means. Arithmetic sequences. So this is going to be real focused. I almost like that better. It's easier. They all follow the same kind of pattern. So again, this is an arithmetic. So my learning target is I can identify and I can generate it myself too. So an arithmetic sequence, it's a sequence where the difference between consecutive terms is constant. Okay, so the difference between consecutive terms is constant. It basically means you're adding the same number every time. Now the common difference we call or the difference between the consecutive terms. So between consecutive terms, that is the common difference. So the common difference is a thing you keep adding. So on this one, identify. So is it arithmetic? Am I adding the same thing every time? And then what is the common difference? So here, what does it look like? Okay, well, and you can always take any term minus the previous. So 10 minus 7 is 3. 13 minus 10 is 3. 16 minus 13, 3. So yes, that is following that pattern, and it's 3. The common difference is 3. It's a positive 3. 7 minus 12 is negative 5. 5 minus 7 is negative 2. So that's no. That's not even arithmetic. So it's not the same difference every time. This one, 5 minus 10 is negative 5. Negative 5. Every difference is negative 5. So yes, and the common difference is negative 5. Here, subtract. No, that's not the same. Difference of 2, difference of 4, difference of 8. It's following something totally different. So for arithmetic formulas, we told you, the recursive formula and the explicit formula. On day one, you kind of had to just figure it out. Well, today it's this. This is it every time. So you're just following this formula. So to write the recursive formula, first off, say what a sub 1 is, which will be given. Has to be given in the problem. And then a sub n equals a sub n minus 1, which just means the previous term, plus some d, which is the common difference. So d is the common difference. N is the term number. A sub 1 is the first term. A sub n is just some random term, a sub n. So a sub 5 would be a sub 4 plus a number, the previous term. Now the explicit formula for this, and the explicit means to fast forward to any term you want. This was kind of hard to do in day one, but today it's just got to follow this. You just got to do a sub n equals, you're going to plug in your first term, so that should be a number, plus your common difference, that should be a number, and then n minus 1. So these you'll plug stuff in for. A sub n and n minus 1 are going to stay variables. It's almost like x and y. Those will stay variables in your problem. Okay. So down here, I got my first term is 5. So a sub 1 equals 5. Again, I'm writing the recursive formula, so I'm sticking with this. And then any term you want to find is the previous term. And then what's the difference? We'll take 1 minus 5. It's negative 4. Negative 3 minus 1 is negative 4. These are all different, so minus 4. The difference is negative 4. Here, a sub 1 is negative 32. Let's find the common difference. Take any term minus its previous. So negative 20 minus negative 32. That's actually plus 32, so that'd be 12. It's increasing by 12. These are all increasing by 12. So any term is going to be the previous term plus 12. Okay, so this is a spot to plug in for, add 12 to it. And so in here, the first term is a half. Any term you want to find is going to be the previous term. And then what's the common difference? Every one of these, if I subtract all those, it's plus a half. So I'm adding 1/2. Now, explicit formula. So think this guy up here, explicit formula. I'm going to do, let's see here. So let's find the common difference first. So the common difference was negative 4. That's from up here. And then I'm going to do a sub n equals the first term, which is 5, minus 4. It's supposed to be plus the common difference, plus d. Well, d is negative, so I'm going to put negative 4, and then n minus 1. Now we do need to simplify this a little bit. So this would be 5, and then that's minus 4n, and this would be plus 4. So, and we want to kind of write this as a linear equation, so x and y. So 5 plus 4 is 9. So a sub n would equal 9 minus 4n. So if you're trying to find, say, the fourth term, plug 4 in. Now, is 9 minus 4 times 4 is 9 minus 16 equal negative 7? Yep, and that gave me the fourth term. So up here, find the common difference. We already did above, it was plus 12. A sub n equals the first term, and then it's going to be plus d, so plus 12 times n minus 1, and simplify. This is plus 12n minus 12. So negative 32 minus 12 is negative 44 plus 12n. That's going to get you straight to whatever term you want. Okay? This guy, the common difference was 1/2, a positive 1/2. So a sub n will equal the first term plus the common difference times n minus 1. So distribute this out, that'd be plus 1/2 n. That'd be minus 1/2. I got the 1/2 out front here. So a sub n would equal 1/2 minus 1/2 is 0, so it'd just be 1/2 n. You notice 1, 2, 3, 4. The fourth term is 2. Plug a 4 in here. 4 times 1/2 is 2. So we know we're getting it right there. Okay, so flip this guy over. And now we got some different questions here. So here's the arithmetic sequence. 63, 59, 55, 51. Got some questions for you. So write an explicit formula. So first off, let's find the common difference. What's going on here? Take any term minus its previous. So that's negative 4. So a sub n equals the first term minus, or plus d, so this is minus 4, n minus 1. Distribute that out, so minus 4n plus 4. 63 plus 64 is 67 minus 4n. So there's my explicit formula. Now it says find a sub 21. That would really stink, but we know it because we got the formula. So a sub 21 says 67 minus 4 times 21. So just plug 21 in. And so that means a sub 21 equals negative 17. Just type in the calculator. Now they want to know, is negative 21 a term in the sequence? We could keep the pattern going and see if we eventually hit it, or I could plug it in for a sub n. I could just assume that it is and see if I get a whole number answer for n. Because if it's a decimal number n, that means, you know, we have to go a whole number, a sub 1, a sub 2. There is no a sub 1.5, so we can't have a decimal for n. So I'm going to put negative 21 in and solve for n and see, is it a certain number of times in the sequence. So minus 67, and negative 88 equals negative 4n divided by negative 4, and this equals 22. So since it equals a whole number, that means it is the 22nd. It's a sub 22. So that is yes. That is yes, because it's a sub 22. What term is 35 in the sequence? So kind of answering the same question. It's just the same question. I'm going to plug 35 in for a sub n and find out what is n, which nth term is it. 67 minus 4n, subtract 67. So I got negative 32 equals negative 4n divided by negative 4. So it is the 8th term. So what term is it? It's a sub 8. So it's the 8th term. Okay, problem solving. Suppose you have $45. You've saved $45 towards the purchase of a new iPod. You plan to save $8 a week from the money you have, from the money of your part-time job. What amount will you have after 11 weeks? So initially, you have $45. So a sub 1 is 45. And then your common difference here, you're going to save $8 a week. So that's plus 8. And so let's write the explicit formula. So a sub n equals 45 plus 8 times n minus 1. 45 plus 8n minus 8, if you distribute that out. So a sub n equals, now 45 minus 8 would be 37? Yeah, 37 plus 8n. And if I want to find the 11th week, so a sub 11 is 37 plus 8 times 11. And this one should be equals $125. Now the arithmetic mean it's a fancy way for saying average or mean. And what it's used for is if you're trying to find this number that's between two other numbers in a sequence. So if you're trying to find a sub n and you know a sub n plus 1, the next number, and you know a sub n minus 1, the previous number, and you're trying to find this guy right here, well, the way to do it is to add these two together and divide by 2. Okay, so a sub n is going to equal a sub n minus 1 plus a sub n plus 1 and divided by 2, kind of the formula that meets it, but for the most part just think add them together and divide by 2. Find the average of the two numbers. So find the missing number here. So I would take 50 plus 92 and divide by 2. So that's 71. If you check, plus 21 is 71, plus 21 more is 92, so the common difference must be 21 in that one. Now this one here, I got to add these two together. So I got 5a plus 5a minus 6. I'm going to divide by 2. This won't be an answer. It's just going to be an answer in terms of a. So this would be 10a minus 6 divided by 2, which would, if I divide everything by 2, that'd be 5a minus 3. So that'd be the number between it. So it looks like my common difference is minus 3. So 5a minus 3 would be 5a minus 3. Subtract 3 from that, it's 5a minus 6. What if the previous term is 39, the next term is 15, what's the middle term? So 39 plus 15 divided by 2. So that'd be 27. Okay. Now how about find the 17th term of a sequence given these? Now, normally we would need, you would think, well, I need the first term. I need to find the first term. I need to write the explicit formula. But don't think too much on this one. Because if you know a sub 16 is negative 5 and you're trying to find a sub 17, if the common difference is negative 9, subtract 9 from it. So this would be a negative 14. Well, over here, a sub 18 is 22, but I'm trying to find a sub 17. The common difference is 15, so something, so a sub 17 plus 15 equals 22. I had to add 15 to get to 22. So I'm going to subtract 15 from both sides. That means a sub 17 must have been 7. Okay? So just kind of a basic problem solving there. So let me know if you have any questions.